Hey everybody, it's Brandon from STEM Tutor Club, and today we're going to talk about this exponent property, the power of a fraction rule. So before we get started, let's actually try to use the rule and just see how it works. So as we start off here, we'll try to calculate this fraction raised to a certain power in two separate ways, one with the property and one without. So starting without, we can literally just do 2/3 times itself 4 times, so 2/3 times 2/3 times 2/3 times 2/3, and you can evaluate this in a calculator if you want. If you do, you will get this number right here. So it turns out that this can actually be represented as a fraction, but for right now, we're just going to accept the decimal answer. And now, on the right side, we're going to try to use the property and see if we get the same thing. So if we just pattern match here, we can see that we have 2 in the numerator, and that's what usually we call x. So x will be 2. 3 is in the denominator, that's y. And then the power that we're raising it to is 4. So m is 4. And then the left side of the equation will be 2 over 3 to the fourth power. And the right side of the equation will just be the same as right here if we substitute in these values. So if x is 2, we'll have 2 and then raised to the mth power. M is 4, so 2 to the fourth power in the numerator. And then in the denominator, we'll have 3 to the fourth power, according to the same logic. And we could also simplify these so we know what these equal. So 2 to the fourth power, that's equal to 16. And then 3 to the fourth power. If you don't remember this, this is equal to 81. And we can evaluate that. If we actually evaluate this, then you'll see that we get this right here. And you can see that this is actually the same decimal as we got before. So this decimal that we got without knowing the property actually happens to equal 16 divided by 81, which is what the property says that it should equal. So you can see whether we use the property or not, we get the same answer, which is a good sign. That's just testing that the property works. But now let's try to understand exactly why it works. Now, as usual, when we're trying to understand exponent properties, the best thing that we can do is use the definition of exponents to list out the multiplication. So if we have 2/3, the fraction, raised to the fourth power, then the definition of that is 2/3 times itself 4 times. So we'll write that out. 2/3 times 2/3 times 2/3 times 2/3. And then after we get to this point in all of our proofs, we generally have to consolidate the numerator and the denominator somehow using exponent properties. So what we can do is we can put all the numbers in the numerator together and multiply those. So we'll do that 2 times 2 times 2 times 2. And then in the denominator, we'll have 3 times 3 times 3 times 3. And then going backwards from what we originally did, we can see that the definition of 2 times 2 times 2 times 2 would be 2 to the fourth power. So in the numerator, we'll have 2 to the fourth, and then in the denominator, we'll have 3 to the fourth. So here, this is the property at work. You can see that these two are actually equal to one another, and that's what the property says. Now let's try to show this result a little bit more abstractly. So instead of using actual numbers this time, we'll just be using variables to represent the numbers. So the way we can write this out is we'll have x over y times x over y dot 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 x over y, and then the total number of fractions here are going to be m. So we're going to be multiplying m of these x over y fractions. And then we can do basically the same thing we did above with actual numbers. We can do that with the variables. So we can do x times x in the numerator, consolidate the numerator, and then consolidate the denominator. Again, we don't know exactly how many x's or y's are in the numerator or denominator, but we know that there are m in both of them. And then here, hopefully it's clear why this would be x to the mth power, and this will be y to the mth power. So here you can see we get to the same result when we do it this way. And this is what the property originally showed. So we started off with the left-hand side of the equation, and you can see that just by writing out the properties basically with exponents, we ended up on the right side of the equation, which shows that this is really true. And just one other note, the only thing that you can't do with this exponent property is have y equal to 0, because you still can't divide by 0. So that's still a rule, but anything else, any other values for x, y, and m, you can still have those, and this property will always be true. So I hope that made this property make a lot more sense, be sure to stick around as we go over the rest of the exponent properties that you'll see in your algebra class.